Welcome. My name is Whitney Lee. I'm a developer advocate, and I'm here with Pete. Pete, will you introduce yourself, please?
Hi, I'm Pete Wall, and I am a software engineer at Grafana Labs.
Awesome. So Pete and I just had a conversation that was almost 2 hours long, where we filled this board full of information about Kubernetes monitoring. It was such a fun conversation, and now we're going to recap it here for you who don't have time to watch the 2-hour version, which I respect. So Pete, let's start out. Will you give some context about what is observability and why do we need it at all?
Right. Observability is really about understanding what's going on inside of your system. And there's a number of reasons why we would want to do that. It's, to fix issues. We want to find issues before they cause problems for the people who are using our software. And we want to really just have confidence that the software we're building is good and that the platforms where we're putting them are also performing well and healthy and happy.
I hadn't equated good observability with confidence before, but I really like that pairing a lot. So then we talked about the signals, common data types in observability. And when you talked about the signals, I was familiar with 3 of them, but you put in a surprise 4th one for me too. We talked about the 4 signals in Kubernetes and in observability.
Right. Yeah. So a lot of people are familiar, especially with logging. Logging is something that we're all very used to creating. Everyone's first program is a hello world program where you write that string to the terminal. And really what that is it's a very much a basic log statement. But logging gets much more complex than that. It can add a lot of metadata inside of the log with structured logs, different formats like JSON or things like that. Really, metrics can be almost about anything, but the really key thing about metrics is that they're tagged with a timestamp. So it's about something that happened at a specific time, and it has some sort of numerical value. And then we also add a lot of labels to those metrics, and the labels help us differentiate one measurement versus another measurement. And then we talked about traces. Traces is tracking an event that goes through a system that can be within an application or it can be across multiple applications. It's tracking through a system. And then profiles. Profiles was the new one that I introduced. Profiles is gaining a lot of steam within the observability space. It's being added to observability systems as kind of a core observability metric type or telemetry type. And profiles are very similar to traces, where they track something happening through a process, but it's less about like this happened, this happened, this happened. It's more about through all of those different pathways, what was the performance of that? And we're looking specifically not for failures, but for like performance bottleneck.
So you're looking at like big trends. So it's still time-based, like metrics, but in this case, we're looking at bigger, like scoped, something more large. We talked about why observability is good. We talked about some things that we're measuring when we're observing our systems. But then what does it mean to monitor Kubernetes?
In Kubernetes is the platform on which we put all of our applications. And I was saying a couple times that a Kubernetes cluster without applications is really not useful, but the applications need to live somewhere. And so this is where, this is going onto our Kubernetes cluster. And so why do we want to observe and monitor Kubernetes? It's so that we understand what's going on with the cluster itself, with the goal of either improving performance, capturing those issues, again, building confidence that this is a solid platform for us to put our applications. And that's, it's important.
So when you can monitor your Kubernetes performance, you can improve your Kubernetes performance. And some example dimensions we talked about are like bug fixing or cost or right sizing or energy or even application performance. Maybe the goal is running your Kubernetes cluster efficiently. But then what does efficiently mean? What is that?
Right. Yeah. Efficiency in Kubernetes monitoring, the idea there, the goal there is making sure that the platform, the Kubernetes cluster is running well with regards to what you want to put on there. So you want to minimize wasted resources, which means you're running a cluster that's completely over-provisioned for the applications. It's mostly sitting idle, doing nothing. That's not helping anybody. And so you want to avoid both of those. You want to optimize. That's kind of more like CPU or memory resource efficiency. But we can also look at things like cost. Are we paying the right amount of money for what we're getting out of this? Are there ways for us to move things around or change our applications or change where we deploy them to make it cost a little bit less, or even energy use. So there's a lot of different variables where we can optimize efficiency for. But really, it's about the health of the applications on that cluster, and it's about what are they using, and are we okay with that?
All right. So we have a sense of context. We have a sense of our goals with monitoring Kubernetes. So now let's get into some of the nitty-gritty details. How do we find and capture logs in Kubernetes?
Well, there's different kinds of logs that we want to look at. The log format that a lot of people think about when they look at Kubernetes cluster would be the logs that are coming from the pods themselves. So pod logs. Pod logs, they're captured by Kubernetes whenever a container sends something to standard out, standard error. It's the hello world program that we all talked about. So when the container emits standard out, Kubernetes says those are the logs for that, and really they're actually stored as files on every node of the cluster. We can always go back, find the log for that, and then hopefully find out exactly why that pod died. Another type of log file that gets stored from Kubernetes are from the node components themselves. So the kubelet does not run as a pod in the cluster, so it's not emitting logs in the same manner that the pod logs are. But the kubelet will log to its own location. We want to get that to make sure that the kubelet is being healthy and everything is going well there. Our cluster events. So if you have ever done a kubectl describe and you've seen things like pulling the image and starting the pod and things like that, those are cluster events. And those are also logs that we want to capture because that helps us understand what state of the application are we in. Did we get stuck at the image pulling and the application didn't even start, or did we get beyond that state? So
3 different types of logs that Kubernetes emits, 3 different locations where those logs are.
Right. So
now what do we do to actually capture that information?
There's a number of different ways that we capture that. What we'll do is we'll deploy a special program that we call a collector. The collector will go inside of our Kubernetes cluster, and it knows how to access this location. The most common pattern that I see is to deploy it as a daemon set, which means one instance of the collector will go on every node of the cluster. That way you can give it a special volume to access those pod logs at the file level. And it would get those by talking to the API server. Hey, API server, send me the events as they come in, and I'll make sure I record them as logs. And if it's a daemon set, it can talk to the node and get the node logs, like the logs from the kubelet. There are alternative ways to deploy collectors. Another common pattern that we see is to use a sidecar. And so in that manner, the collector is deployed in parallel with the pod that's generating the logs. And so it's right next to it. It can still get those standard error messages. It can be used to get other log files that maybe it's putting inside of a special file path. Gives you a little bit more flexibility in how you capture logs, but potentially could do a little bit more overhead workload-wise because you might be deploying extra sidecars than you might need. And you don't have the ability to get the node logs because it's not a daemon set. It might not have permissions or accessibility into those levels. But it's about different ways to deploy these things to get the different information.
So that takes care of logs. And then we moved on to metrics. So similar to logs, Kubernetes has 3 different ways to emit metrics. What are those 3 ways in Kubernetes?
Right. Yeah. So Kubernetes has kind of 3 built-in categories I'm thinking about when it comes to metric sources. Many of the control plane components have their own list of metrics, and those are really helpful if you want to know, for example, how the scheduler is doing. Is it able to keep up with its demand? Same thing with the API server, the controller manager. They'll have the metrics that talk about the internals of that component. Are things going well? The kubelet writes metrics for its own internal health, but also about the pods that it's deploying. So the pods that are running on the system that are deployed by the kubelet, the metrics that the kubelet emits is about itself, but also about those pods. And so it starts to capture some interesting information about how the cluster, like what's on the cluster, right? Another component is called cAdvisor. cAdvisor runs parallel to the kubelet, so it's on every node of the cluster. cAdvisor looks at every container and captures things about the CPU usage, the memory usage, all of that really interesting low-level details about what's going on at the container level. So those are all built into Kubernetes. We didn't have to add anything for those.
And then you tell me that all of these metrics, they're stored in memory. And then when a collector comes around and asks for the metrics, that's when they're handed off to the collector. You said that's called scraping, which I just think is like such a visceral word.
Yeah,
and like
really.
as often as the scraping happens, it's a scrape interval is like how often to collect these metrics. Is there like a recommendation for how often to scrape for metrics?
Right. Yeah. So the most common scrape interval that I've seen is about 60 seconds. So once a minute. You can go faster. Okay. That will get you more data points, but all of that extra data you need to store somewhere. You can go slower. You can bring it down to 5 minutes, 10 minutes, or something like that. But you start to lose a little bit of the granularity. If you go super slow, you may have things like pods will start and stop between the measurement points, and so you might not even see anything. So you don't want to go too slow.
So I am psyched to get this storing, but before we do, one thing that kind of bogs me down or like is overwhelming for me about observability is the idea of metrics. Like there are so many zillions of things. That's the technical. A bajillion. Besides these Kubernetes built-in things, you highlighted some very popular tools for collecting other types of metrics. So let's talk about first the node exporter. What's that one about? Up
until now, the built-in ones talk about how the cluster components are behaving and a little bit about what's happening inside. But what Node Exporter says is, I want to look at the actual machines where the cluster is running. I want to make sure that that's healthy. And so Node Exporter, it gets deployed as a daemon set, and so it's on every node. And what its role is to look at the underlying, actual physical hardware that's running this. So it's a virtual machine instances where these are running, looking at the CPU, GPU, if you have one of those installed, memory, disk space, all sorts of information about how the actual machine that's running the node of the Kubernetes cluster, how that's performing.
That makes a ton of sense. How that would be, that would supplement this collection very well, this information very well. Tell me about the kube-state-metrics or KSM.
Kube-state-metrics also generates metrics about the cluster, but it's an interesting kind of perspective on it. It's less about like a measurement of CPU or some sort of like numerical scale that we typically think of. But what it does is it builds metrics about the state of all of the objects inside of the cluster. So a good example would be I create a deployment with 3 replicas. Initially, no pods are running. I just pushed it to the cluster. But then over time, 1 pod starts, 2 pods starts, 3 pods starts. What kube-state-metrics does is it will build a metric that says, for this deployment, what were the number of desired replicas is 3. And then what's the actual number of running replicas? Initially it's 0. And then a new scrape of the metrics will say 1. And the next scrape will say 2 and then 3. And so what we can use KSM metrics to do is tell us, do we have the desired state of what we're deploying? And in a point in time, like 3 out of 3, that sounds great. I can see maybe it's 3 out of 3 now, but is it 3 out of 3 always? Or was it like, is there a pod that's crashing and then it's coming back online and then crashing and then coming back online? And so seeing maybe a little dip in the trend.
Is it useful to be like, how long is the deployment taking? Like it's taking a really long time now when it used to take a short time. Is that a use case?
No, yeah, definitely. So you can definitely do that where because all of these metrics are time series, you can make a calculation, you can make a visualization about show me all of the deployments that have less than their desired number of replicas. And show me the time and place where it was deployed to the time where it actually got, fully fulfilled. And you could do some measurements around that and maybe, capturing some interesting information about the performance of how quickly are we bringing things online.
Next, you talked about OpenCost. What's OpenCost?
Yeah, so when we were talking about why Kubernetes monitoring? We were talking about efficiency. We're talking about what are sort of the things that we want to optimize for. There's the resource optimization. We want to make sure we're using our CPU and memory well, but there's also cost optimization. Ultimately this stuff costs us money to run, and it could just be the hardware that we purchase, but it also could be a cloud bill that we're paying to some other organization. OpenCost looks at the resources that we've deployed, so it knows how much some of these things cost, the nodes cost, the cluster costs to run, but it also can look at, this deployment, it's using this much CPU and this much of a slice of that node. So this deployment is costing you this much. And so that can help inform, is it time to up the number of replicas? What's that going to apply, not just in terms of CPU and memory usage of new replicas, but even cost amount of new replicas.
I think it's so cool that it knows the real-time cost. It knows what cloud provider you're using and the real-time cost of the type of infrastructure you'd be adding should you upgrade. That's super cool. And then the last one we talked about was Kepler. What's Kepler?
Kepler, similar to OpenCost, where OpenCost looks at the cost of your deployments, Kepler looks at the actual real-world energy usage of those deployments. Mm-hmm. Kepler knows, it talks to the node, and it knows about the type of processor that it's running. It knows about how much literal watts of power it uses. And then it can look at the deployments, how much CPU those deployments are using, and how to slice that up. Since obviously cost makes sense. Do we want to pay for how we change things? But why would we want to care about the energy usage? For obvious reasons, it would be nice to minimize how much power we're using. But it can give us information about when we create new versions of our software. Can we compare the energy usage? And that's an indication of the performance of the algorithms or how well internally things are working. But also, can we compare wind or solar or something like that versus a data center that's using more traditional power generation means? And can we say, hey, we can move stuff from this kind of more less environmentally friendly place to the more environmentally friendly place, and we're not going to lose any performance. We're not going to lose any runtime.
And it feels good to have real data that backs these decisions instead of it seems like it'd be nicer, but to really understand exactly the impacts that you're making by making better choices.
It's measurable. And I think that's the big thing about monitoring in general. You want to put an answer to these things rather than just a hunch.
So of these all four very important signals, we spent most of the time talking about logging and metrics and just maybe a little bit of time talking about traces and profiles. We give us an overview. We'll maybe answer the question, why is it smaller on our board? And then an overview of what we talked about.
With the perspective of Kubernetes monitoring, meaning monitoring your Kubernetes infrastructure, metrics and logs play the biggest role of that. Traces and profiles, they more slide into the application observability, which is still hugely important. You want to understand that the applications you deploy on your cluster are running well, and understanding how they are doing. But traces and profiles are really useful for the app developers of those components. There are some components within Kubernetes that create traces. The API server is one of them. But your typical platform engineer who's deploying Kubernetes is not going to be looking at the traces for the API server because they're not the primary user of those. The typical use case is going to be people who are deploying apps to Kubernetes. They want to look at the traces for their own apps. So the box is smaller because it's less kind of a core data source for infrastructure monitoring of Kubernetes. But all of these things, they lean on each other. The information you get from your application, you may inform more stuff from the logs, the metrics, the stuff that you read about or you capture about your Kubernetes cluster information. It helps you kind of give an overall picture about what's going on.
Coming to the end, we talked about all the different types of logs, so many types of metrics, just the tip of the iceberg there. Then collecting them, and then we need to store them. That's so right. One thing I found interesting is each type of signal, each type of logging, metrics, tracing, I guess, profiles too, each of them has their own database type. So we talked about what's important for a logging database to make it a good database for logging.
The important thing about logs databases is the ability to not only get all of this log data and store it efficiently, but also make it very fast to query that information, to find interesting trends out of that information. If you have gigabytes and terabytes of log data and you're looking for very specific patterns, you need to be able to have a really kind of rich query language that you can say, hey, show me stuff from this cluster, from this namespace that has this regex inside of it. And then, bring me that information within a couple, less than a second. And then I can start to really get that information quickly. It's about the speed of getting the information, as opposed to just looking at the log files themselves and just trying to scroll until you maybe find something that slows everyone down.
That's a really funny mental image. I'm just scrolling for days, just looking for one particular log.
Right.
So then when you say for metrics, so there's a whole different type of database that you would want to store metrics in. Would you say the bottom line is you want to be able to query it quickly and easily? It's just metrics just need to be stored differently to achieve that same bottom line?
Right. I mean, effectively, yeah. A metric-specific database, a time series database, it's the one factor for all of these databases is how do you store things efficiently? How do you optimize where you can? Because it's a lot of data that we can capture. But another really important thing is how do we get that information quickly? And so a metric database will have different methods to find all of this information. With the time series bound of it, it's going to be things like a 3 hours chunks of time 2 weeks ago because something interesting happened back then. And so how do you get that specific time period for those metrics really quickly? Yeah.
And so all of this hard work we've done to collect and store all of our logs and metrics, our reward is visualization.
All of this data is really cool and interesting, but it doesn't really help us unless we can turn it into something that we can look at and go, I got it. I know what I need to do. I gave the example of, if I've got a hard drive in my computer. And so one metric is the total amount of space that's available. And another metric is just the total capacity. And I could look at those two numbers and see, okay, space available goes down and capacity is this number. But until I turn it into, here's a gauge, and I can see, it's about 70% full. That tells me something way faster than just two numbers. And so when you talk about at the Kubernetes monitoring level, the visualizations that you build and the dashboards that are available, the idea is to tell a story that really gives you the impression of, I know exactly what's going on inside of my cluster. I know how efficiently I'm using my cluster. And I know that I can put more apps on there because we've got the space for it. I can have the confidence to make sure that's all going to run.
How can visualization help you understand unknown unknowns? Things that aren't even on your radar that could go wrong.
Right. Capturing all of this information, we're putting it into the database. Often we are capturing more information than we're actually visualizing in a dashboard. And so we can always use that to say, hey, there's something else here. I'm going to start talking to these databases, pulling those metrics, pulling those logs, and then turning those into new visualizations. There are lots of other tools out there that we didn't get a chance to that talk about how do we just look at things, even if we haven't made a dashboard for them, but see if we can identify trends or correlations or things like that. And so, yeah, that's always a great question. How do we know what to ask for before we know what to ask for?
I want to tell the future. I want observability to help me do that.
Right.
Thank you so much, Steve, for sharing your time and expertise with us today. It's been such a joy to have you here. Thank you so much.
I've had such a great time. Thank you so much.
Bye.